Good morning, students. So for the past 2 weeks, we are discussing this phytochemistry practicals. Okay. So in the continuation of our discussion, today we are going to do the experiment, the extraction of caffeine from tea leaves. So if you take the tea leaves, which contain the mixture of compounds, mainly these two compounds. One is tannin, another one is the caffeine. Okay. So tannin is a polyphenolic compounds. This caffeine is a alkaloids. Mainly it is a purine alkaloids. So the question is coming, why we have to extract this caffeine? What are the use of this caffeine? So if you see here, it is mainly used as a CNS stimulant, and it is used in sinuses problem. It's in order to cure the sinuses, we will take this compound. And finally, it is used as an addictive in analgesic agents. So it will increase that effect. Okay, that's the meaning of addictive. So these are the main uses of this caffeine. So if we take tea leaves, this is present in high composition, 3.5 percentage. Okay, caffeine, it is present in tea leaves, 3.5 percentage. So the main difficulty is these two compound is present. So how we can extract this, mainly this caffeine from tea leaves? First, you have to take the tea leaves, add water, 100 ml of water. 20 grams of taking means add 100 ml of water. 10 grams of sodium carbonate or sodium sulfate. You can take 5 grams. You can add a mixture of both sodium sulfate or sodium carbonate also, no problem. Okay, and heat that solution for 2 to 3 hours. After 3 hours, take that hot solution, keep and digest the solution and filter the solution. Take the filtrate. In hot condition, both the compound it will came out from the tea leaves. Filter, take the filtrate and add into the separating funnel. Add chloroform, 75 ml. Add 75 ml of chloroform. So why we are adding? So this is the advantage of this caffeine. The caffeine is a compound, it will dissolve or soluble both in water as well as in chloroform. But the tannin is insoluble in chloroform. So that is the key factor. That's why we are separating the caffeine by using this solvent extraction method. Okay. So take the aqueous extract, add 75 ml of chloroform to the separation process. The bottom layer is a chlorinated layer. Take that chloroform layer and repeat this procedure for 2 to 3 times. Combine all the chlorinated layer, evaporate, you will get the impure caffeine. Okay, take that sample, add ethanol, do the recrystallization process, you will get the pure white crystalline powder. That is nothing but caffeine. So in order to extract this caffeine from tea leaves, we need 10 grams of this tea and this 10 gram of sodium sulfate and two 5 ml beaker, separating funnel, measuring jar, 100 ml measuring jar, chloroform and this distilled water. So first you have to take this beaker, add this 10 gram of tea, add 10 gram of sodium sulfate and then add 100 ml of water. Add this water into that container. Gently stir the solution. Heat the solution for 2 hours. Kindly add the porcelain bits. So after 2 hours of heating the solution, the next one you have to filter. So in this extract we have both caffeine and tannin. So remove all the junk particle by doing filtration process. So the main idea of the separation is this extract which contain both tannin as well as the caffeine, but tannin is insoluble in chloroform, but caffeine is soluble in chloroforms. So after this filtration, you have to take the extract and you have to do the solvent extraction process. Okay, so we will wait for another 2 minutes for this separation process. I'm going to add this into the separating funnel. Take 50 ml of chloroform. Add into this separating funnel. So when you compare the water, this chlorinated solvent is higher in density. So the bottom layer is a chloroform layer, upper one is a aqueous layer. So you have to do the solvent extraction. So you have to hold this tightly and you have to release the pressure. You have to release the pressure and do the okay. Do the solvent extraction process. So after separation process, we will see the two layers. Bottom one is the chloroform layer, upper one is the aqueous layer. So in this chloroform layer only the product will be sent. Okay. So gently open this knob and collect the chloroform layer. So collect the pure chloroform. So we are collecting the chloroform layer. Here we have some aqueous particle. Okay, we can remove that aqueous particle by adding sodium sulfate. So the sodium sulfate is a dehydrating agent. So take some 10 gram of sodium sulfate. Go and take 10 gram of sodium sulfate. So now we collected the chloroform layer. Okay. So now to remove the moisture, this solution, now I am going to add little amount of sodium sulfate, which is a dehydrating agent. Take some amount of sodium sulfate, add in this solution. So add some chloroform. Could you able to see? Could you able to see here? It removed all the moisture from the solution. So now we got a clear chloroform solution which contain the caffeine. Okay. Filter this. Take in an RB. So here I am going to take the 250 ml RB. Decant this solution carefully. So now I got the pure chloroform extract. Evaporate this, you will get the compound caffeine. So after evaporation, we will see the caffeine. So we taken this chloroform extract, we evaporated, and we got the crude product of caffeine. So in order to convert this to pure caffeine, you have to do the recrystallization process. Take small pinch of this impure caffeine in a boiling test tube, add ethanol, heat and cool it, you will get the pure caffeine. You have to confirm the product by do the melting process. The melting point is 263 degrees centigrade. If the temperature, that confirm the presence of caffeine.